Then, to move on to our next topic, we have Chithra B. Menon and Nithin AR. Chithra is a lead NLP engineer at IBS Software. She specializes in leveraging natural language processing technologies to optimize airline passenger services, air cargo management, loyalty programs, and flight and crew operations for leading global airlines. Nithin is a senior solution engineer at IBS, specializing in digital innovation and transformation, NLP, AWS, Django, and Angular. Their topic for today is transforming airline loyalty support with generative AI on AWS. Please welcome Chithra and Nithin.
This accomplishment or development has highlighted the potential of generative AI in the real-world challenges. So in our topic, transforming airline loyalty support with generative AI on AWS, we are mainly focusing about the challenges addressed by the loyalty members, airline loyalty members, with their queries, like redeeming their points, understanding their tier benefits, or even updating their personal details. So traditionally, there would be a person or a human agent that would understand their queries, while in email or in their chat, they would understand their emails and would respond to each and every emails. So here we have developed an AI-driven automatic response system that would generate responses automatically for the frequently asked queries in a more context personalized and effective way. So let's see how the traditional airline loyalty management system works. So a customer will send a mail to the airline managed mailboxes. A person will be sitting there and parsing these emails and creating service requests for this in the management system. And again, another agent will be there to process these requests and respond to the customer. So the challenges faced by these systems are the high volume of customer emails. Like there will be a large amount or fluctuating or diversified amount of data or emails coming into the system. So it will be very difficult for the agents. It will be time consuming or even increases their loads, resulting in the customer experiences. So the next will be manual response limitation. So each and every agent will be tailoring responses, or it will be repetitive task, and they will be tailoring all these responses and creating or sending these to each and every person or each and every customer. So this is very a monumental task for these agents. And depending upon the person, it may different. The tune will be different. The details that they share will be different. So this also lead to the overall customer experience. So we have developed a solution that would incorporate all these challenges. And the key objectives of the solution is, one is the selective automation. Selective automation is like that. We will be generating automated responses for the frequently asked questions, while ensuring the more complex queries will get the human attention that they require. We'll be using a dynamic knowledge base that would have star-specific information. Here it is airline-specific information, and would create responses which is context-aware. And the complex issue that needed to be passed to a human agent, like it, for example, if that needed a human attention, or need to create another service request based on this customer queries, it will be given to the human agent with some context related to that queries. So the next key is personalized responses. So each responses will be tailored in such a way that it depends upon some factors like sentiment. We'll be understanding the sentiment of the customer and tailoring the responses accordingly. That would lead to more professionalism and empathy. The next will be the issue type. Issue type is categorizing the queries into different issues, whether that can be automated or handled by the human agent. The next is prioritizing the issues. Prioritizing the issues based on its urgency and resolving it based on those urgency will increase the customer experience. The next key object is the historical data references. When a customer sends a mail to the system would refer the past interaction of that customer with this management system and would give a context, would take that information or that past interaction as a context to respond to this system in a more personalized way. Or if it is beyond the automation, if it is needed to be handled to the human agent, what it does is it gives this interaction as a context, and the human agent will get an idea of how this customer would behave or how this customer's query has been resolved earlier. So the next objective is robust and scalable. If this airline management system is having a large amount of flexible and diverse queries or data, so we need to handle these flexible data along while ensuring it is integratable with the existing workflow. So the system should be scalable and robust. So for example, we can use AWS Lambda for scalability, or S3 or RDS for reliability and robustness. So this is an abstract design of the solution that we have developed. So we'll be having an airline mailbox where the customers send their mails. We'll be having a Lambda, a mailbox reader, that would read these mails from the mailbox and push these mails to SQS or RDS for storing. And we're having a backend service Lambda that would pull these mails from SQS or RDS in a timely intervals. So we have created a knowledge base with the help of documents. The earlier past, it can be the past interactions, the Q&As, FAQ, everything, which is stored in the S3. And we use a knowledge base with the help of Titan embedding, for the enhanced search. And for open search as the vector storage, we have created a knowledge base that with the help of Bedrock LLM model, Cloud HiQ, and this knowledge base, the backend service would create the responses. Either it can be an email itself, an email content, or the context for the human agent, and will be passed to the loyalty management system. So I'll be giving the session to Nithin.
Thank you, Chithra. So now comes the exciting part, where we get to talk about LLMs, prompt engineering, etc. So as in our previous sessions, Sandeep has mentioned certain points regarding how prompt is done and everything. So prompt engineering is basically biasing the output of an LLM by giving it more context and giving that output that is required for us, not that perhaps the LLM was trained on. So this will be something like creating the output that is specifically required by us. So, but the thing is, for the industry, most of the time we need reliable and reproducible outputs most of the time, and it should be accurate also. And this is easier said than done, because this is all an empirical science, but that we have to test and reiterate again and again of the prompts in order to get this. And you cannot always solve all of this in theory. So in our system, we experimented with many LLM models that are provided in the AWS Bedrock. And for us, Cloud Haiku performed better. So we'll be diving a little bit more into prompting for Haiku. Yeah. And let's come into something for the philosophy of creating a good prompt and prompt engineering. The first thing that we need to do before writing down the prompts exactly is that we need to develop test cases. And ideally, these test cases should be something like, we have to, this should represent our distribution of data most efficiently. And you should always take care about handling those edge cases. And this is the places where most of the time the LLM will struggle, and you will have to modify most of that. So you need to identify how the LLM performs in these outlier cases. And it is also important to notice that you shouldn't just simply create a prompt that will pass all of your test cases. It is so easy to create a prompt and overfit your test cases. So you need to take care that it should also generalize well. And once you get there, you will have a preliminary prompt. and you have to, then from there you can test these prompts against your test cases, reiterate them, and see where it does well, where it is not doing so well, and you can repeat this process until you get a good enough answer for yourself. And from there, you can deploy this into your application. So even if you do not conceptualize everything that I'm about to say later, if you follow this particular philosophy of prompting, you will arrive at a very good result for yourself. Now, for Claude, the thing is that each of the LLM is different. To get that reproducible and reliable output every time, you need to understand how the LLM was particularly trained on, what the data it was given, how the data structures it was trained on, and notice the tips and tricks where you can tweak the output of the LLM so that you can get that output that you require for yourself. So this is kind of universal to almost all the LLMs out there. That is, you need to be clear and direct in your instructions or in the prompt. So the thing is that sometimes LLMs will output a certain preamble, like there is a pretext before the actual output that you need, and this will cause problems for yourself. So you need to specify and explicitly say that you shouldn't do that preamble text, and these are sometimes mostly left kind of empirical and iterative in process. So you need to specify these instructions in your prompt. And this is why we say that in prompting, you should speak to the LLM like you are doing to a 3-year-old. You should be explicit, clear, and direct in your instructions in your prompt. And from there, we'll go more deep into Claude-based prompting. So Claude is trained specifically to understand these kind of input prompts. That is a kind of human assistant conversational interaction between them in the prompt. So human part will be the instructions for the LLM, and assistant is where the Claude's response should be. So this is like, this particular formatting is different for different LLMs. For example, in GPT 3.5 Turbo, it is system and content like a JSON-like structure. But for Claude, it is human and assistant prompting. And if you follow this particular special tokens, you will get better results in your prompting. And that is important because even the first interaction, human interaction in the prompt should also have this particular new line token, human, and the semicolon, colon is also critical to this type of formatting. Now, next is something very common to all the LLMs, that is assigning roles to your prompt. So this is something like you have to put Claude in a particular role where it is more suited for your application or the task that you're trying to accomplish. That means even for a simple type of application, Claude will perform better if the suitable role is assigned to it. In this example, you can see that a puzzle is given to the prompt, and it performs better if it is assigned as a master prompt logic bot or puzzle solver. And another thing is that assigning roles also improves accuracy of the output that you are desired to get. In our use case, it also made the prompt a little bit more robust against out-of-context questions. Okay, now moving on. This is also using XML tags to delineate from Claude's outputs is also something very specific to Claude. That is, Claude is trained to work exceptionally well with XML type documentation and to separate different sections within the prompt. So you can see in this example, without that particular delineation, it is hard for the prompt or the model to kind of understand where the separation for the task, that is separating the email where it starts and ends, particularly is. And this is more important when you get to longer prompts or if you are trying to get a certain kind of output formatting from the prompt. Okay, moving on. Yeah. And speaking about output formatting, it is something that we do extensively within our applications. That is, you would want certain output format like JSON in your application so that you could do some post-processing for the output and you can parse the output and certain keys from there. So JSON is a very common output format, and you can specify in the prompt that you want the output as a JSON format, and maybe it can be list or JSON or whatever you need. And sometimes, as you seen in an earlier example, Claude will put a long preamble in the text that is before your desired output or maybe after your desired output. This can be annoying because this can be hard to do post-processing from, and it also incurs in cost and the latency of your system. So what you can do is, that is something very specific to Claude. You can start the response for Claude from there. You can see that they have specified the starting of the JSON structure there. This basically instruct the model to skip the preamble and go directly into the output of the model. And these are some of the very basic things that are in the prompting specifically for Claude. And there are other things also, like handling hallucinations, thinking for Claude, and speaking for Claude, and making Claude able to say no, that if it doesn't know a particular answer, give that permission to the model, and of course at the cost of a few extra tokens. Okay, so coming back to our application, what we did was we did another thing called as prompt chaining. Maybe Sandeep has already touched a little bit on that part also. So we wanted to extract the metadata from the email and like sentiment, priority, and identify the issue type also before generating the actual output. So we separated that into two distinct prompts in our workflow. So first we did was we gave that one to a preliminary prompt or first level prompt, if you will, and that one extracted the metadata from there, of course in a JSON format. And from there, we also consequently we used AWS knowledge base for getting the similar conversation from the prior historical data that was provided within the S3 servers. And we gave all that information into a second level prompt that identified, generated the actual email output that was required by the agent. And it also took into consideration all the metadata extracted and also the similar conversation prior done by agent and the customers. And that's about it. This helped in reducing our application helped in reducing the reliance on agents for creating every single response by themselves. And it consequently helped in increasing their agent output and by giving a tailored and more personalized response every time. And this also helped in scaling the application, fitting to seasonality, changing in volume of the email from customers. And it also helped in some sort of monitoring and tracking and reporting of the analytics part also. And that's it. Thank you. I hope you had something useful from this session.
One question is, like, I really like the way in which you handle the JSON. So that was something very new for me. Okay, maybe I'll go back and try that, especially when you want to start with the starting point of where the JSON, because always I had the problem with the preamble, but I solved it somehow. But let me try this one. So that was a very good information. Wanted to ask about the guardrails. Have you tried using guardrails within Bedrock?
Yes.
Or are we using it?
Yes,
Because
yes.
even with Sandeep's previous thing also I forgot to ask.
Yes.
But guardrails, how useful it is, and what kind of
Yeah.
guardrails are you basically implementing into your system?
Yeah, the thing is that we have only shown a very concise diagram for the application. That is, we are also using guardrails because we are handling very sensitive personal information from the customers directly. So we do have some profanity sensors and all applied to it, but I cannot divulge them entirely, but we are using guardrails in this application.
One more thing is that is every data available only with the AWS ecosystem, or are we using a combination of cloud agnostic? Is it
No. Everything is within our AWS VPC only. Okay. So protecting the private data from airlines is of prime importance because of even with GDPR and all, we need to have the data within our servers in the VPC of the airlines. And we do get some requests from customers for deleting their data also. So that all needs to be tracked.